I should finish the problem. So here it says, find where the slope of the curve is defined. Ooh. So really, I'm looking for where it's not defined, and then I'm going to write down everything else. Slope of the curve. I think that means I got to take the derivative. And I got x's and y's in here, so I'm going to have to use implicit differentiation. Okay, so, well, I'll do that. I'm taking the derivative of both sides. I can distribute the derivative operator. I'm going to show every step, not really. I'll show what I think is important and what you can handle. I think. I mean, like, okay. So, yeah, I'm going to distribute the derivative operator, and then I'm going to take the derivative. Here, these agree, so I can just take the derivative like normal. This is just 3x squared. Oh, that's very nice. These disagree. In fact, we actually had that already. So, what is ddx of something that disagrees? Remember, you take the derivative like normal, okay, and then you tack on a dy dx. That's very easy. All right, but then over here, I have two functions multiplied together. So I have to use product rule. So first, d second, the derivative of y is just 1, and then you tack on a dy dx. And first d second plus second d first. The derivative of x is just 1. Okay. Now, I need to find the derivative. That's still the first step. Find the derivative using implicit differentiation. And then I'll interpret stuff. So, to find the derivative, I need to solve for dy dx. So I will subtract this over, and then I'll also subtract that over. I'll do it in one step, like a giant, because they have really big steps. So I'm just gonna double check. This I subtracted over, so it should be negative. That's why I have the negative there. And I left that alone, so that's why it's positive there. And I subtracted this over, so I should have a negative. Yep, look at that. And then this one stayed on that side. Okay, then I will, because I'm trying to solve for dy dx. I'm trying to find the derivative. So I'm solving for dy dx. So I'll factor out a dy dx. That's pretty easy. So then I get that. I just factored out a dy dx. And it left me with 3y squared. Oh, look at that. And minus x. There we go. And then I'm going to divide both sides by 3y squared minus x. So on the bottom here I'll have 3y squared minus x. And that's what I have for my derivative. But that's not the answer, because it wasn't asking for the derivative. It says find where the slope of the curve is defined. So here's an equation for the slope of the curve at any point x comma y. And I have y minus 3x squared divided by 3y squared minus x. That's very interesting. So here are my thoughts. This gives me the derivative if I plug in an x and a y. However, I know that the derivative is only defined where the denominator is not equal to 0. So I'm going to say, well, when does it equal 0, huh? Well, that equals 0 if I set it equal to 0. I'm finding out the x comma y's where it equals 0, and I'm just going to solve for y. Just because I want ordered pairs. I want y comma something over there. That will be, like, y is the dependent variable, so I'm going to have it by itself. X is the independent variable, so I'm going to make it like it's going to be y is going to be a function of x. That's what I'm doing. So I'm solving for y right now. That means I'm adding the x over. So I get 3y squared equals x. Divided by 3, I get y squared equals x over 3. And I square root both sides. And that gives me plus or minus the square root of x over 3. Okay, so where is the slope of the curve defined? I mean, I don't really have actual values because there's a bunch of places where the slope is undefined. I think. Yeah. So, what do I have? Well, I have the square root of x divided by 3 and comma y. Okay. I think I said it backwards before. And then also any point that follows this form, x divided by 3. And I'm going to try and graph this, or I'm going to look up the graph and see what the heck is going on, because it's really this curve, and that's, I think, a sideways parabola. So like any point on this sideways parabola, there will be a slope that's undefined. Any point. Now I'm going to try and graph that and see. Like, it's confusing. What am I graphing? I'm not graphing this. This is where the slope is undefined. I'm graphing this because I want to see what it looks like. That's a super interesting graph. So the graph of this looks like, I just looked it up. I'm not expecting you to graph this. It's actually kind of weird to graph in a graphing calculator as well, because it's you can't solve for y very easily. But it looks like a loop. I missed. It looks like a loop here, but this point, I mean, I can tell just from here, that's going to have a vertical tangent, so that's where the slope is undefined. Maybe here it's going to have a vertical tangent, so it looks like only 2 spots, but I mean, we have 2 points. Maybe those are the only 2 points where this is undefined, where it has a slope that's undefined. Let's see what the graph of the derivative looks like. So where's that? That's this thing. So I'm going to take a look at that graph, just to try and make sense of it. I can't even. This graph is insane. It looks so cool. I'm going to try and draw it real quick. There's this like loop right here, and then it kind of looks like something like that. And also we have something that's really like jagged, and that, I mean, that corresponds to this, because we have, it's not differentiable at any of these because they're like custom point, and it's actually probably like infinitely like oscillating in between there. But that shape definitely looks like this graph, which we said before. This is crazy. Really, I mean, this is all like crazy stuff that you won't be able to really graph on the AP test if you're not able to use a calculator. Actually, even if you were able to use a calculator, it's kind of weird to graph. But the general idea is to find where the slope of the curve is defined. We would, I guess I didn't even answer the question. No, I didn't. So find where the slope of the curve is defined. That would be, well, you would take the derivative, and then if you get a fraction or a natural log or something, you have to find out where that function is undefined. So if you had a natural log, anywhere the inside was 0 or negative. If you had a square root, anytime the inside is negative. If you have a fraction, anytime the denominator is 0. So to actually answer this question, find where the slope of the curve is defined. You would say defined at any place except whenever y equals plus or minus the square root of x divided by 3, because the derivative, oh, that's so cool. It's crazy to understand, but really all we're doing is taking the derivative and seeing where the derivative is undefined. The derivative is undefined when the denominator equals 0. So that was a long example for a problem that isn't going to be that hard. You're just finding the derivative and setting the denominator equal to 0, or finding out where the derivative is not defined. So we'd say defined at any point except one that falls on that graph.